Hello everybody. In this video we are going to review the solutions to the right hand rule practice problems. Before we get to looking at the actual problems, I just want to review a couple of things with you guys. First, if you guys remember way back in September, I know a long time ago, but way back in September, one of the first lectures and PowerPoints that we went over, we talked about coordinate systems and we were first learning about one-dimensional motion. And we reviewed our coordinate systems that we typically use, right? We usually have an x-axis that is along the horizontal plane, and we have, this is my x-axis here, let me just write an x, and then we have a y-axis along the vertical plane. So there is my y-axis. And I know that we defined to the right on the x-axis as positive, to the left on the x-axis as negative, and up on the y-axis is positive, and downward on the y-axis was negative. And if you remember, there was another axis, the z-axis that I mentioned, and the z-axis actually comes out of the page and goes into the page. And this is my z-axis. And I told you guys back in September that we don't have to worry about the z-axis until we get to magnetism, which is going to be sometime in April. Well, today is that day that we have to worry about the z-axis. And here's the picture that we had from that video or from that lecture way back in September. And our z-axis is actually coming, if we're looking at the screen here, or if you're looking at a piece of paper, the z-axis is actually coming out of the screen or the page or into the screen or the page. So I know, again, my x-axis is horizontal, my y-axis is vertical, but my z-axis right here is going to be both, or is going to be coming straight out of the page and straight into the page. And we define the positive z-axis as coming out of the page. So it's coming from the page or the screen right to your face. And the negative z-axis is going to be going into the screen. So if you were to hold a pen up and it was going to be perpendicular like this, like my pen here, let me see if I can do this, perpendicular to the screen, the z-axis is going into the screen, and that's the negative z-axis, and the positive z-axis is coming out of the screen, going straight backward. And the way that we denote that in terms of our notation is that for the positive z-axis, we usually use just a, whoops, let me go back to my pen here. We usually use a circle. And that should be just a circle there. Hold on here. My pen isn't working very well. Or a circle, or I'm sorry, a dot within a circle. For the negative z-axis, we usually use just an X. And the thinking behind that notation is that we usually use arrows to denote direction. And if you think about an arrow, the front of the arrow is a point, and the back of the arrow has feathers on it. So for the positive z-axis, it's like the arrow is coming towards your face, so you're looking at just the tip of the arrow coming towards you. And for the negative z-axis, the arrow is moving away from you, so you're looking at the back side of the arrow, which has the feathers in it, which makes the X pattern. So that would be the notation that we're going to use for the z-axis. One last thing I wanted to mention before we take a look at the problems in this set is that Mr. Broderick did a terrific job of explaining the right-hand rules in the narration for the PowerPoint. I'm going to be going over that as well in these problems, as well as a lot of the other problems that we're going to be looking at over the next couple of weeks. But this can be confusing, and it's hard, this is a very visual thing, and it's going to be very hard for us to kind of get the point across to you guys without being in front of you and actually being able to show you and do things with our right hands. So there is a video, a very good video from YouTube that explains the right hand rules, and I have posted a link to this video on my website. It's in the same place that you'll find the magnetism PowerPoint. So the same place I put the PowerPoint for magnetism, there's a link to this video. I would strongly encourage you guys to watch this video and watch this this explanation about the right hand rules. The video is only about 8 minutes long, but it is a good reference tool for you guys to be able to understand these right hand rules. So go on to the website, click on the link for this video, and please watch it at least once, because it will certainly help you understand these right hand rules, because we're going to be doing a lot of that over the next few days, a couple of weeks. Let's take a look at problem number 1. We have a current flowing through a wire generating a magnetic field. They want to know what is the direction of the current. So the line here, let me just see if I can draw this. This line right here represents the wire. And I know on the wire, if I look at the notation on either side of the wire, on the left side of the wire, we have these dots. Those represent the direction of the magnetic field. The dots mean that the magnetic field is coming from the page or the screen directly towards me. It's coming out of the screen towards me, and that's the positive z-axis. On the right-hand side of the wire, we have these X's. Those X's denote that the magnetic field is going directly into the page. So we call that the negative z-axis. So on the left side of the wire, the magnetic field is on the positive z-axis. On the right side of the wire, the magnetic field is in the negative z-axis. So if I hold my right hand up for this right hand rule, I'm going to hold my hand. I know I'm covering my face. These videos just got a lot easier to watch, didn't they? All right, so I'm going to hold my right hand up. And I know this is reversed because it's on the screen. I'm not doing this in front of you, which might make it a little bit more confusing. But on the left-hand side of the wire, the magnetic field is coming out of the screen and into my face. And you can see I've just curled my fingers to go towards my face. And then on the other side of it, and I kind of have to twist around a little bit like this, but on the other side of the wire, magnetic field, now my fingers are pointing towards the screen. They're going into the screen. And my thumb is going to give me the direction of the magnetic field. So when I hold my thumb up, it's telling me that the magnetic field, or I'm sorry, the current is going in the upward direction. So I know that the current, in this case, is going in the upward direction, or in the positive y direction. Problem 2. We have a magnetic compass is placed below a current carrying wire. So this shows me, wait, let me just get the right color here. This shows the current carrying wire, and the current is flowing out of the page. So that's what this dot in the middle of the circle tells me, that it is flowing out of the page along the positive z-axis. And they want to know what is the orientation of the compass. They want us to label the north and south poles of the compass needle. So again, I'm going to use the right hand rule. I'm pretty sure all the problems in this set of problems or in this worksheet are going to deal with just that first right hand rule that Mr. Broderick went over with you guys in the video. And because I'm doing this on a screen, I'm actually going to use my left hand, even though these are the right hand rules, and you always need to use your right hand to find direction. I'm going to use my left hand because it's going to be kind of a reverse image and show you guys things in the right orientation. So I know the current is coming out of the page, and my thumb represents the direction of the current. So if I place my thumb going towards my face, or coming out of the screen, if I curl my fingers around, it's going to show me the direction of the magnetic field. So as I curl my fingers down, I know on the left-hand side that my magnetic field is going to be pointed downward. So I know that the magnetic field is, let me just try writing with a pencil. My magnetic field is going to be going downward or to the south. And if I continue that, if it curls around, and I'm trying to make this happen without breaking my arm, when I get to the right-hand side of the wire, the magnetic field is going in the upward direction. So now my magnetic field on the right-hand side is in the upward direction, and that is going in the north direction. So on the left-hand side of the compass is the South Pole, and on the right-hand side of the compass is the North Pole. And you'll notice when you do the right-hand rules, when you're moving your hand around, you're going to be in some kind of funky, awkward positions. That's normal. And it's kind of fun to do. It's fun to watch me do it. It's always fun for me to watch you guys do it. I'll miss out on that opportunity as we go through these remotely, but I'll be thinking of you guys twisting your arms in all sorts of funky positions. Problem 3. We have a electric current flows to the left as shown below. They want to draw the magnetic field lines due to this current. So again, if the current is going to the left, and I'm using the wrong hand here, but because I'm giving you a reverse image. I'm using my left hand. Always use your right hand for this. Remember, my thumb is the direction of the current, so I have my thumb pointing to the left or the same direction as the current. As I curl my fingers around above the wire, my fingers are going toward the screen or toward the page. So they're going in the negative Z direction. As they curl around the wire, when I get below the wire, now my fingers are coming out of the page and coming toward my face. So that is in the positive Z direction. So if I am going to write how this goes, above the wire, it was in the negative Z direction. So it was going into the page. And underneath the wire, it was in the positive Z direction. So it is coming out of the page. For some reason, it doesn't like drawing here. Let me see if I can do this in highlighter. That might be a little bit easier. There we go. So it's coming out of the page, so there should be little circles or dots. It doesn't like to draw little circles or dots here. I don't know why, but that should be how that one looks. Number 4 tells me that the electric current is flowing into the page. So the electric current is going in the negative Z direction. And they want us to draw the magnetic field lines, including the direction due to this current. So if my current is going into the page, my thumb needs to be pointed towards the page. So my thumb is pointed toward the page. Let me just get it centered there. And as I curl my fingers around, you can see my fingers are curling in a clockwise direction, and they continue to go clockwise. I'm trying to do this here, but they continue to go clockwise around the current. So my current, or my magnetic field, is going to be going in a clockwise direction around the wire, like so. Problem number 5 says that the electric current flows toward the bottom of the page. So the current is going downward or in the negative Y direction, and they want us to draw the magnetic field direction at point P. So again, if I'm going to hold my thumb downward, as I curl my fingers around to the left-hand side of the wire, you see my fingers are pointed toward the page or toward the screen, which means that they are going in the negative Z direction. So on this side of the wire, I know that the magnetic field is going to be in the negative Z direction or into the page. Problem 6, it says indicate the direction of the electric current that would generate the indicated magnetic field. So in this problem, they show us the direction of the magnetic field, and they want us to determine what direction the current would be going in to generate this magnetic field. So if I look at this diagram, it shows me that the magnetic field is going in a circular motion, and it's going in a clockwise direction. So again, if I hold my fingers here and I want to curl my fingers around in a clockwise direction, so my fingers are pointing towards the same direction as the current, and as they kind of curl around here, they're going in the clockwise direction. If I point, my thumb is going to give me the direction of the current, and we see that my thumb is pointed toward the screen, right there, toward the screen. So that would be in the negative Z direction, or into the page. So the current is going to be going into the page, or the negative Z direction. All right. Again, I know these can be confusing. We're going to be practicing a lot more. We're going to be doing the other 2 right-hand rules as well. This is really hard to show in a video. One of the things I was really concerned about as we went to distance learning was how to show you guys how to do the right-hand rules. We're just going to have to practice a lot of these. Again, watch that video that I referenced at the beginning of this presentation, and post it up on my website, because that does a really good job of explaining it as well. If you have any questions, just shoot either myself or Mr. Broderick an email, or just come into one of the Google Hangouts that we'll be having during our regular schedule. So let us know if you have any questions. Otherwise, I'll see you when we go over some homework problems tomorrow.